Hello everybody, it's Holger Mueller here from Constellation Research, talking to Raju Vegesna from Zoho. He's the chief evangelist over there, and we're talking about which interesting topic today, Raju?
Let's talk about some of the topics that nobody is talking about, Holger. That would be interesting. The hottest topic lately is sovereignty. We're hearing a lot about it. I'm curious about you. Do you hear that much lately?
No, it's a great topic. It's definitely the topic which has been brewing on the surface and starting to get actionable for the first time. If you look at the public cloud vendors, right? Amazon announced a massive investment in Germany, building their largest sovereign cloud region in Brandenburg. At some point, it will be only operated by EU passport holders, having the full stack available there. So there's definitely an awakening call on digital sovereignty, which is a legal requirement on the one side, but also a performance advantage for having all these complete cloud stacks available in each country. So definitely something that's happening. 2026 is probably the year of sovereign cloud.
And one thing I've noticed is AI has become the trigger, but now everything is looked from that lens. One of the questions that came up recently in some of the discussions across some countries was, hey, if you look at the military organizations, you say you control the physical borders. Do you control the digital borders? In a lot of cases, they are checking everything and realizing that, hey, sovereignty is not just one on and off button. It's either you're sovereign or not. Obviously, it's a spectrum. And where in that spectrum do you really fall into? And at every aspect, like, are you sovereign when it comes to, say, power, energy, which is an age-old question? And are you sovereign when it comes to trade? Are you sovereign when it comes to, say, finances? Are you sovereign when it comes to, physical security, digital security, data, and all of these?
Exactly.
And AI is actually, recently I've had this conversation in Canada, and they're saying, we have data sovereignty, and we have data here in the cloud. And that is, we are mandating the data to be within the country. But they forgot to ask one point, and I said, your data sovereignty rules are outdated. You're saying, hey, you're requiring the data to be in the country, but imagine data being a book, and today you are asking the book to be in the country, but somebody can walk in, read the book, and then walk out with the knowledge. Then the book stays within the country, just that knowledge walked out of your country. And what happened to your sovereignty there? They're not asking that question. The data residency question is what they're answering, but they're not asking the knowledge question. In the AI world, knowledge is the thing. Are you noticing that point?
Yeah, that's a great point you raised, Raju, there. There's one more aspect of sovereignty which I want to add, which is judicial sovereignty. So if something goes back, you have a chance to sue someone. Not that it guarantees that you'll be compensated, you might witness and so on. If the actors are outside of your country, there's pretty much no recourse, right? So that's one of the key realizations here. So if it's in the country, you have recourse, whatever it will be good for. And that in a very litigious world, in a very lawyer-centric world, in a very compliance-centric world is a big point. Yeah.
And to add to that, I think there is also the aspect of AI, for the most part, being a black box. Even if you get into that legal path, there's no way to trace back and prove that, hey, you used that intelligence and your, I would say, specific info for a particular path, and that it becomes a path without any clear direction. So I think these are all unknowns we have to figure out.
Absolutely. There's a realization, though, which I think will be a challenge to digital sovereignty. Which is two things, right? So we are known to the concept of data gravity, right? Data attracts data, and more data comes to the data, which is an interesting effect here. And you have to be able to store the data. I think the innovations of scaling data infrastructures are now there that you can provide the local data centers to reach that. But now there's a GPU aspect, right? And GPU gravity is real if NVIDIA, which is pretty much the standard options to run things on premises, keeps up their innovation cycle so fast with their next generation architecture being so much more capable. Because what we will see ultimately is agents talking to agents, And if my agent can't run through more scenarios, spend more tokens, right? It might be more expensive or not. Then my agent might win the battle with your agent who's running on an old NVIDIA machine or an old other architecture, right? It might even come to the point where I say, look, I'm charging you extra because it's more expensive for me to do business with you because I'm waiting for your agent for 10, 15 minutes or for 1 or 2 minutes, whereas my agent's always ready, right? So that's a fear and concern, and that could whoops all the digital sovereignty plans on the data side to say, I need to be close to these fast GPUs, to these fast AI architectures to have the transactional advantages on my agents.
I mean, now the sovereignty is one of the discussions. What I'm sensing here is we have had recently, there has been some security related discussions in the context of AI. Sovereignty is one.
Yep.
Privacy, abuse has been prevalent in the industry. There is obviously the cost advantages, cost challenges and all of that. Now, with a lot of this happening, do you see the pendulum swinging back to on-premise? Because, I see this pendulum going back and forth. We've seen the centralization with mainframes and the decentralization with the PC, and then now with the cloud compute and all of that centralization. But with all of these challenges like sovereignty, privacy, security, price, all of these, do you see the industry shifting and the pendulum shifting back to on-premise?
There's definitely a shifting back to on-premises, right? Microsoft, if you like the history of that, started that with, back then was Azure Stack, being able to run for certain workloads things on premises. The things which are challenging there is that for very few, I call them the next generation computing platforms, which allow you to run on premises, but allow you to move the workloads, right? Because for companies, it's super, super difficult to write software. Once they have a working asset and software, they want to use it. They want to use it in different locations, right? You might have sovereignty laws coming up and you have to bring it in country, right? Famous example is Russia, customer, employee data, and so on has to be stored inside Russia on Russian servers. But be careful Russia so much at the moment, and it will be difficult to enforce, different problem. But you want to have this workload portability. But to achieve that workload capability, you need something which I thought analysts love this, right? Create a new term, which is identicality. But identicality on the same stack in the cloud and on-premise is really, really hard to achieve. Now, this was all before we had the AI question, like how do you make your agents run and hum, right? And the important thing is right now, we remember a year ago, we were all talking, enterprise will build their own LLMs. The question was, how big will they be? How layer cake will they be? Nobody's talking about this anymore because we're on this agent mode and just use AI to understand the intent, maybe then generate some SQL. And that SQL runs on classic infrastructure. So there's a good way back for the on-premises part from that perspective, because if your on-premise architecture scales, it's a good thing. Yeah, there's a performance argument, so but we'll come to that, right? Which we might want to talk about headless or not, right? So.
Yeah, no, at a macro level, on one side, I'm seeing the pendulum swing towards the on-premise, and arguably one of my theories is this will also enable deglobalization, and my own at least theory there is, if you go back to globalization, one of the technologies that enable globalization, especially in the physical world, I would attribute that to the container ships or the containers per se, shipping containers. That pretty much significantly reduced the cost of distribution. When you significantly reduce the cost of distribution, then the production moves to places where there is abundance of talent or it is affordable. Right? Now, on the digital side, obviously the technology that reduced the cost of distribution is really the internet. So which means the services ended up moving towards where it is cost effective, where the talent is available and all of that. Now, all of a sudden, you have with the digital side, the creation is becoming easy because there are two aspects to a product, creation and distribution. Distribution has been cheaper, but for the first time, the creation of these digits have become cheaper. Now it's pretty much raining digits at this point with all these LLMs vomiting digits. So now with that context, now when digits become cheaper to create, now all of a sudden, now it can be closer to where the problem is. And that's why the concept of globalization, which existed because of the cost arbitrage, may shift towards it. It's a duality here. On one side, we have pendulum swinging towards on-premise. On the other side, we have the deglobalization, where production moving closer to where the problem is. That's why I would attribute the rise of the FDEs and all of those in that realm. It's an interesting combination we are noticing. I'm kind of sensing a broader global shift here. I'm just curious to get your take on this.
Yeah, it's super, super interesting. Like, I love your maritime analogy of the container ships, absolutely with you for shipping products. And there's also an interesting thing in maritime history is, right, remember we had wooden sailing ships, and you could not build them so large because the structural integrity, rigidity of wood is limited. Even if you get the best, most strongest wood, you can't make the ships longer to a certain amount, you can build higher masts to a certain amount. Along came the steamship, right, which could build built of iron, had the engine for that, would run with no wind, right? So the steamships were here. And then in the 1890s, 1900s, the sailing ships came back, but they were not built in wood, they were built in iron. So you had the longer ships, you had the higher mast, they were more economic to run to, but ultimately we don't transport stuff in sailing ships anymore, right? And there's some new tech things which I love in sailing ships which are coming back. So I think we might see the wave to back on premise in the long run, maybe when you and me are dead, right? I think it's going to be like a similar discussion like the steam engine, which was invented, needed coal to be powered. So only societies which had coal reserves could use it, right? So England, France, Germany were strong on steam engines. India on the other side, Japan on the other side, economic powerhouse now, only really got industrialized with electricity, because electricity put the generation of the power and the localization where needed to run machinery, turn on lights and so on in two different places. Yeah, what we're seeing right now with AI, we see that knowledge, artifacts of knowledge, are being automated in agents. Yeah, so we see for the first time that knowledge can be taken in different places and be operated in different places. And I think the pendulum will always swing. I think in the past, for production, we tried to say with my sailing ship example, it swings back with a new technology, right? We could make an industry example, a Snowflake, right? Snowflake uses the data warehouse, super well understood, 80s concept, 90s used in every enterprise. They put it in the cloud, they get elasticity from the cloud. CEOs know, I know the technology, I'm going to use the technology. And I didn't think it would have a second life, because we know that data warehouses are not very agile to adopt to business reality, right? If you're lucky, 2-3 days to change dimension tables. I'm sorry if I'm getting too technical. So I think the pendulum swings back, and the fact that it swings back one more time is the preparation for the final swing. So in the long run, I don't know when, I think it will be all public clouds. The question is how many of them will be there around.
And in the context of that swing, it's not just the clouds and the intelligence. I'm also saying the services aspect to be integrated with software, services Absolutely. Plus software. I mean, FDE is only part of it. Now, I would say maybe this FDE concept existed for a long time. I often say, hey, if you look at an accountant is an FDE to some extent in that particular accounting realm. And there is later, in fact, the fact that the big four accounting firms like the Deloitte and Ernst & Young and PwC, KPMG, these companies started as accounting firms, then became consulting firms. It tells you that concept worked. Now, instead of just focusing on finance, you're expanding that operations and calling it an FDE. But just that those are consulting firms. Now, consulting firms combined with the creation, where you have the services implementation offering solutions alongside creation and vertically integrating alongside your own cloud possibly and delivering the outcomes. I see that entire market merging and shifting the economics along with that. That's at least in the current state. That is what I see as the current direction. Do you see anything different?
Absolutely, great point. Companies need a lot of help and services to adopt to new technology. And I think this is why we see the popularity of the forward deployed engineering companies and public companies are being asked, are you adopting the FDE project? As a technology analyst, I don't like it so much because it means the product isn't ready. But I need help to get it done. And that's where the big disruptions coming from AI, that you can use AI to implement and use products. We haven't done this yet. The question is, when will it start? Right? I don't know. Right? I think it will start sooner than later, because implementing, handholding, doing things is getting easier with AI. Right? We see that on the software side, where we have a massive revolution where software is being generated. I have nightmares who's going to maintain the code because we have a maintenance problem already, right? So, but it shows you how suddenly the step by step along the value chain, AI changes things, and that also includes implementation, right? So I think the FDE is a one-time new technology, and there might be new technologies, right? I cover quantum, right? The implementation of the first quantum, there will be quantum consultants probably to build the code and Tantel. There will always be service new technology, but the maturization and AI automating that will be much, much faster, right? Thinking about the factory as an example, as you brought up factories, local factories, the first robot factory is around the corner. Yeah, and the humanoid robot, right? Not the industrial robot we see in the car industry and so on, right? Humanoid robot will be around the corner.
And one thing I do wonder is if you are jumping into the intelligence and the investments in that too early without giving it enough time to mature. And today, I would argue the amount of money that is being put in, 700 billion every year, it's still a little early in the game. And if you look at just the energy usage of it, it's not efficient compared to, say, other industries. For example, brain uses about 20 watts, and NVIDIA GPU uses probably 600, 800 watts of energy. Now, generally, when we have created something, it is supposed to be more efficient, and hopefully we'll get there. I mean, compare that to solar. Plants consume, say, convert maybe 1 to 2% of solar energy into energy, while our solar panels can convert it about 20% or so. But we haven't gotten to that efficiencies in the intelligence yet. And I'm guessing that maybe that 1000x or maybe 2 to 3 orders of magnitude efficiencies are yet to be gained in the AI world. And in looking at our own industry, like the transistors and whatnot, we have seen about 1 million x improvements in the last few decades, and we haven't gotten to that yet. Are we, as an industry, as it usually happens, are getting too excited? And is there any investor exuberance that we are seeing that is pouring a lot of money without the technology itself is maturing? I sense that is the case. What's your take on this?
That's a great point, and definitely it's a gold rush, right? So gold rush being 1849 California, right? I mean, people back to the ships, right? People would sail in, landway was long, and the ships would get abandoned, right? And ship was a major capital investment for everybody, but the employees did not care. The captains did not care. Everybody was trying shovels, were super important and super expensive, as an example, just to make it to Sacramento to go on Mr. Sutter's land. And here's the sovereignty issue as well, right? So people were stealing the gold from the gentleman on which property Sutter was found. But there was no law enforcement in California. It was Mexican at the time, and Mexico was controlling California with 80 soldiers. There was no chance against 1,000, 5,000, 10,000, 20,000, 100,000 gold rush people to do something. So we will have negative side effects here. There's no question about that. The key thing for an enterprise is the affordability, right? As an enterprise, you always look, what is the TCO? What is the ROI of using technology and getting something out of it? Should AI get too expensive, right? It does not make sense. You will hire people again, right? There's enough people. The bar where the cost will be slanted a little bit, where in first world countries, there's not enough reproduction and the human labor cost is higher, right? We see this already, different things happening, and big driver to what you mentioned before, globalization. So yes, mistakes are being made in the gold rush. We are in a gold rush. People will lose money. People will lose their shirts, no question about it. The appeal, so what's different, right? As a technologist, we always been excited about technology, right? And there's been the business you said, oh, let's wait for it a little bit, let's wait for it to mature. The Europeans would say, oh, there's a new thing from the US, let's wait 2-3 years, maybe it's fake, we don't have to use it, right? And in some cases, like, remember the metaverse, right? Who's doing the metaverse, right? Maybe the metaverse is coming back at some point, but right now, if you didn't jump on the metaverse bandwagon, I mean, your business is running fine. Let's do it. This would have been an investment nightmare, right? How Zuckerberg justifies it to shareholders is up to him, right? But the agentic automation part is so powerful that the non-business people realize that, oh my God, I can do things, right? I was at the NVIDIA show floor. There's a startup, I shouldn't mention it, right? They have industrial roboter, which you can train with a tablet, which costs you fully loaded $20 an hour. Yeah, the use case, their first customers in manufacturing, and the biggest thing is they can't hire the people. Plus, and that's what every board member says, agents never go to sleep. They don't have a bad day. They don't get sick. There's no vacant position for an agent, right? Which should lead us to the back-end conversation, but I'm talking too long. So what are your thoughts on this?
No, I think the investments, I agree. There is an exuberance here, over investing being technologies getting excited. But then there is other side to it. The ones that are investing are the ones with the deep pockets. And that means the number of companies that invest will be limited, or they get to dominate. And it takes us back to this sovereignty discussion. Like at the network layer, 95% of broadband or fiber pretty much backbones are pretty much owned by private companies.
Hmm.
If you look at the cloud computing layer, again, there is a dominance at that layer, with maybe a handful of companies controlling majority of the compute. Similarly, the model layer, again, it's limited. And if you look at the top companies out there, top 5 tech companies out there, their annual revenues are probably at the range of, say, GDP of 75% of the countries. And so that means, to some extent, in a lot of cases, there are a lot of companies that are bigger than countries. And at some point, companies start to control countries. Coming from India, I know that realization, where I see the modern version of, or a digital version of, the East India Company or the Dutch East India Company, all of that. I see similarities there. So that is what makes some of these countries uncomfortable. That is also the reason they are asking and having the sovereignty discussions. And now they are kind of pushing back, whether it is trade-related discussions. And certainly the recent trade discussions are waking them up. During the COVID, their reliance on some supply chains are waking them up. So whether it is a physical supply chain or a digital supply chain, and they are noticing these investments that are pretty much at the bigger than the military scale investments of several countries, they are raising the sovereignty questions. And that's what I'm seeing. That's why the sovereignty discussion keeps coming back. Just curious, do you see something similar?
Absolutely. Sovereignty, like I said, 2026 is the year of sovereignty. It's really, really hard to do if you want to be competitive. Yeah. If you want to have national digital sovereignty and sovereignty for your clouds, you have to attract the investment. And like you correctly said, that will work for large economies. But until we saw them playing great football, right? Until you build your data centers in Capo Verde, I'm not sure if you're still in this business, right? So not for respecting it, right? So it's possible conversation for probably the top 10, 20, 50 countries on the planet, right? On the flip side, it's all good business, right? Building a small case digital sovereignty data center in Capo Verde, to say the example, is good business to be the first one there. So there's enough competition, luckily, from the cloud scaler perspective. And now comes the part, right? The difficult part of building is CapEx, like you absolutely said, but then operating them is difficult too. And again, I'm hopeful on the AI side, for AI to manage stacks automatically, we have the situation already from a cybersecurity perspective, right? How can I protect an enterprise with human speed when I have AI speed attacks, right? So it comes back to, again, I need to have the GPUs platform to run AI speed to protect myself. So I think that the can of worms, once you start to implement digital sovereignty, is going to make it a luxury problem. And the problem is, once you implement it, and it's great that AWS is doing this in Brandenburg in Germany, not for it being in Germany, but for doing this in general, and we'll see how up to par, and they have the commitment, it will be up to par to US East, which is their most advanced instance where all the new stuff comes in. Again, data gravity, we know that well, right? Data gravity, that's why US East, the government is there, all the federal data centers are there. If they can keep it up to speed and how quickly GPUs or whatever the platforms will be, right, will be running, so I can have cutting edge, at least inside of the EU, cutting edge AI automation, building my models as fast as my friends, competitors, partners, suppliers in North America, and so on. Super interesting to see. Yeah.
And it is in the interest of all the other countries who may not have the same resources to invest in the alternatives. They may not have the capital to invest in a lot of these. That means it is in their interest to move these models to the edge, keep it small, high context, lower sized model, and obviously better energy consumption, all of that. I see some of these innovations coming on that front, but there's a long way ahead. And I don't think it'll be determined in the next few years. It may take a decade or so for this entire thing to play out.
The question is, how far are things out, right? And there's a great quote from Bill Gates who says, we tend to overestimate what happens in 1 year and we tend to underestimate what happens in 10 years. Yeah. So
and we've seen that in the previous bubbles where we over-invested in the .com and certainly internet took off in a big way, but the people who invested in it were not around to capture the benefits of their investments. It goes all the way to railroad as well. The initial people who put in the money to put in the rail were not the ones who captured the profit. It was helpful, but it took a long time to play out.
Yeah, it's a super interesting analogy there. Again, you bring up great analogies here. We were fooled in the .com boom that it was only a connectivity problem. Yeah, it was only a connectivity problem to connect everybody, and marketplaces would be there and the websites would run without, and we haven't talked about it, without the backend systems, right? We could not scale, internet scale, I call it infinite computing, right? Infinite connectivity, everybody's known, the internet is everywhere, has reached every part of the world, pretty much almost all of them. The next level was infinite insights, right? The revolution which came with Hadoop-based technologies where you could affordably store everything without knowing how to query it, right? End of the data warehouse. So that is 2010, 2011, 2012, out of advertisement, right? Next comes infinite compute, and we're in the middle of the infinite compute phase, right? Where you don't have to worry about compute anymore because somebody else brings up the capex to run that compute. After that comes infinite machine learning in the model report. I call it machine learning. I didn't call it AI. I still think we don't have really AI, but it's machine learning. And then on top comes infinite deep learning, right? Where machine learning AI is looking over your shoulder, looking at your task and say, hey, Holger, hey, Raju, look, you did this 3 times. Can I automate this for you? Yeah, where it will run, interesting conversation to have, right? But so we were kind of like fooled by saying connectivity is the only problem. Yeah.
The one difference between that investment that was made in fiber optic connectivity and today's compute investment is, the fiber optic speeds did not change on a yearly basis. Yet the compute power is changing on a yearly basis. The chips that you're going to buy next year are almost certainly going to be at least maybe 10, 20, possibly even 30% better in terms of performance than they are this year. So the capital investment that was made today, that was made back in the day for the fiber optic, kind of lasted much longer. But that cannot be said when it comes to compute investments, though.
Agree that there's absolutely right with that, right? So, and the fiber optic has still room if you look at the utilization of fiber optic networks, right? Because it's a much more of a large jump in technology from copper, whatever you would use before. But the incremental, if the improvement of if the computing platform is incremental, like you use a 486 against a Pentium, right? Unless you're a compute-intensive user, it didn't matter, right? You wouldn't get anything from saying, hey, all my workforce upgrade to Pentium per pass, right? The point now from the AI architecture perspective is, are your agents being able to be better agents? Are your agents helping your humans to save more money? If you keep it an intra-company use case, if you think of an inter-company, between companies use case, will my agents be the better salespeople to a purchasing agent somewhere else? Will my purchasing agent be a better purchase person than the sales agent on the other side? And can I quantify that, right? And that's a big management, when you trust agents for inter-company automation, but that will come along. There's no question about that, right? So, and that's where the CPU granular is. If an NVIDIA, not to put them on the block, if their next generation is more power hungry, only 10% more powerful, well, people will not adopt it, right? And maybe somebody else will step up and provide something, right? Or that workloads will gravitate to them, right? With all the difficulties of that.
Yeah, I mean, there has to be efficiencies that come because I cannot see the current model scaling. A single token requires about close to 200 billion flops or whatnot. There has to be at least 1 or 2 orders of magnitude improvements before we see real value out of it. And obviously, once you see an order of magnitude difference, then you realize that, hey, most of your investments, may not pay off. And that's the byproduct. And this is a hard pill for some of these companies to swallow.
Absolutely right. But I don't see a company saying like what they say in quantum, which is wrong, by the way. We can talk about that too, is it's not ready, right? The use cases are not ready. We can wait, right? And you're probably not wrong if you wait. My saying is quickly as a public service announcement, if you think public state actors will spy on you because you have sensitive R&D and so on, and they might be in the country and outside of the country, you need to be quantum safe encrypted. Yeah. So people can't break, at least for specific R&D, trade secrets, and so on, that you can't be broken in. As a public service announcement, I talk about quantum here. Everything else, agree you can wait. On the AI automation side, companies don't want to wait. And if you look at the cost of the public LLMs, right? I mean, we're in a historic point. We're recording this. Yesterday, Kimi K3 launched, right? The largest open weights model, which is almost the same performance than the pro-pay models, right? There might be an inflection point. The consumer data is pretty much indexed available LLMs, and that means that the LLMs don't get bigger. There's a cost point. The real benefit who we're talking about here, we're not talking about consumer LLMs, is for enterprise to leverage their enterprise data, right? And go to use that to automate and augment workers, help them workers, replace workers, make every employee a manager of 2, 3, 4, 5 agents, which you have to supervise, dramatically change in the future of work for people coming up.
I 100% agree with you. The way I see it is agents are the new office suite. Instead of installing a bunch of tools, you're installing or enabling a bunch of agents, at least as you as an individual. And agents end up using software. So agents are really the interface between humans and software, and humans focus on the outcomes, and agents help you reach those outcomes.
Absolutely.
Any other interesting things you're noticing, Holger?
No, I think we touched the important, interesting points, and we see how this is a journey, right? And obviously, journeys go to certain destinations, and destinations have winners and losers, right? If you look at the NVIDIA, and sorry that I mentioned NVIDIA a bunch of times here, original architecture did not foresee the agentic use case, because agents power CPUs, right? So all of a sudden, the next generation machine from NVIDIA has a large CPU part, and NVIDIA is building CPUs, which 5 years ago you'd say, yeah, that's an April Fool's joke, right? So it shows that even the people so close, the winners, if you want to, most valuable company at one point, whatever, it can't predict where this is going. What I think is there will be a point where we get over agents, because like I said, the enterprise use case of AI is right now minimal, right? Because catch the intent, maybe you generate SQL bit, and then you go to your existing APIs and data. Yeah, I think there's use case to what we were talking a year ago, that there will be whatever sized LLMs which avoid me not to go to that data, not to have that hit to the CPU, not to burn the energy for the 10th time to create customer data. But I know that Holger and Raju talked about digital sovereignty, and that's just in the cache for everybody if they want to ask for that. And when it goes to the cache or in the weights of the model, right? So I think we'll see the more AI in the enterprise, and that's going to be the big demand, because from what we see today is we've reached pretty much the limit. The models are not getting better. The models are not getting bigger. They find new use cases, fantastic for coding. Once coding is done, I don't know what the next one will be, law or medicine or whatever that will be. We'll see where the return of investment is. Exciting time for sure, right? Most exciting time ever, right? You've been doing this technology for a long time, and it's making us thinking in the hamster wheel all the time.
Absolutely. I mean, my own take is, if you look at the next use case, LLMs succeed when they can verify. Verifiability is a primary thing. They are succeeded in coding, or they are succeeding in coding partly because LLMs can verify if something is working or not. If something is not working, they'll try the second one, third one, or 100th time till you verify it. Because if you're generating a piece of code, then it either compiles or it doesn't. The verifiability is out there. But you cannot apply the same verifiability in all those use cases. You cannot verify the output like a drug, where you have to go through the entire cycle of getting it approved and all of that, where the verification cycle is significantly longer. So my own take is they will end up penetrating the industries where you can easily verify the output, and slowly, as they get better and as they get more hopefully conscious, then it'll uncover broader set of use cases. So verifiability, in my view, is the key differentiating factor.
Very interesting. From the practical adoption, we think about verifiability and building the trust and that the model is doing the right thing. What I've seen so far from early adoption is the building trust. If it doesn't work, right? It goes back to the vendor. But building trust outpaces the speed of building models, of building AI automation. Yeah, so it's very interesting, right? The vendors think packaged agent every 2-3 months should be fine. The trust cycle is 2-3 weeks in the enterprise, and people are saying, "Oh, what's the next generation of that agent?" right? So very interesting situation that we're in, because the appetite, like with everything, comes with eating. The interesting thing that we're at the point right now is that humans supervise multiple agents doing work for them. We're still very much stuck in this one-to-one co-pilot setup where you have to wait for the agent. That is not productive, right? For the agent to do something and see if it's useful or not useful, right? So that's the phase we're moving out. And like you said before, it will consume more energy. It will consume more tokens and with that more energy. It will continue the data center race for the foreseeable future, but it has to be cost efficient for the enterprise. Yeah. So otherwise it will come to a stop and will not be adopted, right? Nobody will use those machines, right? So
yeah, and I see this is one part of the problem. AI is the brain, and the body is coming with humanoids, and the real innovation kicker is going to be when these two come together. It's a question of when, not an if. So that's where the technology industry is always exciting.
Okay, so physical AI is going to be massive.
Looking forward to it. Looking forward to having these conversations as things evolve in the industry, Holger. Always awesome talking to you.
Most exciting times in tech, as always.
Yeah.
Thank you, Raju.